What are the ordinates here? A is equal to 2 and B is equal to 4. Area bounded by the curve, area is equal to integral a to b y dx. X square plus y square is equal to a square. Y square is equal to a square minus x square. Y is equal to root of a square minus x square. Y square is equal to x. So x is equal to x raised to 4. You can transfer this to the left hand side. You can take x common factor. 1 minus x cube is equal to 0. Hello dear students, welcome to this session of Mathematics Revision class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to take very important concept, that is application of derivatives. So in application of derivatives you may get one 3-mark question and one 5-mark question. Now what is the weightage for this chapter? One 3-mark question and one 5-mark question, totally 8 marks. So very important concepts. Now let us move on to the first one, area under simple curves. So to find the area under simple curves, let us consider a curve y is equal to f of x on the x-axis and bounded by the ordinates x is equal to a and x is equal to b. If y is equal to f of x is a curve and this curve is on x-axis and the ordinates, what are the ordinates? X is equal to a and x is equal to b. This is the curve. So if y is equal to f of x is a curve and here x is equal to a and x is equal to b are the ordinates, that is OP is equal to x, that is x is equal to a, and that is OQ is equal to b, that is x is equal to b. So the area enclosed by this curve is given by the area is equal to integral a to b y dx, that is nothing but integral a to b. What is y? Y is nothing but f of x dx. So if we integrate this curve, if we integrate this function y is equal to f of x between the limits x is equal to a and x is equal to b, that will give the area of the curve. That's it. So that is the total area of the region between the x-axis and the ordinate x is equal to a and x is equal to b for the curve y is equal to f of x is given by a is equal to a to b dA, that is nothing but a to b y dx. What is a to b y dx? That is nothing but a to b f of x dx. So therefore the area enclosed by the curve on the x-axis between the ordinates a is equal to x is equal to a to b is given by f of x dx, that is nothing but integral a to b y dx. That's it. Now similarly, suppose the area of the region bounded by the curve x is equal to g of y axis. So y is equal to f of x axis. Here x is equal to g of y on the y axis and the lines y is equal to c and y is equal to d is given by area is equal to integral c to d x dy, that is nothing but integral c to d g of y dy. See, if the curve is on the y axis, the area bounded by the curve on the y axis and the points y is equal to c to d is given by, this is the area of the shaded region. So that is given by integral c to d and g of y dy. That's it. This will give the area of the curve on the y axis. Now by knowing this, let us take a problem. So very simple and important problem for 3 marks. So you may expect this type of problem for 3 marks. Find the area of the region bounded by the curve y square is equal to x, this is a parabola, and the lines x is equal to 1 and x is equal to 4 and the x-axis in the first quadrant. So what is the curve given here? Y square is equal to x, and what are the ordinates? X is equal to 1 and x is equal to 4 means a is equal to 1 and b is equal to 4 and it is on the x-axis. X-axis means this is the curve, x-axis, y-axis, you know y square is equal to 4x is an equation of a parabola. This is the parabola. Now what are the ordinates here? So ordinates are x is equal to 1, this is x is equal to 1 and x is equal to 4, x is equal to 4. Now what is required to find? So this is to be determined, the area of this portion. Right. Now here area is equal to integral a to b. What is the formula? Y dx. Right. Now, since it is, what is the problem given? Find the area bounded in the first quadrant by the x-axis in the first quadrant means, so therefore, the area bounded by the curve in the first quadrant means just determine the area of this shaded region. So, that's equal to integral a to b y dx. That is integral, what is a? A is equal to 1 to 4 y. From this, since y square is equal to x, therefore y is equal to square root of x root x dx. Now this can be written as, so this is integral 1 to 4 root x is nothing but x to the power of half dx. Integration of x raised to half is half plus 1 is 3 by 2 divided by 3 by 2 between the limits 1 to 4. Just take this to the numerator, 2 by 3 into, apply the upper limit. Upper limit is 4 to the power of 3 by 2 minus lower limit 1 to the power of 3 by 2. That is 2 by 3 into 4 can be written as 4 to the power of 3 by 2 can be written as 2 square whole raised to 3 by 2. 2 gets cancelled. 2 cube is equal to 8. This is 8 minus 1. 2 by 3 into 8 minus 1 is 7. 7 2 is 14 divided by 3 square units. So therefore, the required area is 14 by 3 square units is the required area. That's it. 14 by 3. Okay. So a very simple problem. Now move on to a similar type problem. Here, what is the problem given? Find the area of the region bounded by the curve y square is equal to 9x. Again, it is a parabola. And x is equal to 2 and x is equal to 4 on the x-axis in the first quadrant. Same type problem. Y square is equal to 9x. Y is equal to root of 9x means this is 3 root x. 3 root x can be written as x to the power of 1 by 2. What are the ordinates here? A is equal to 2 and b is equal to 4. Area bounded by the curve. Area is equal to integral a to b y dx. Now, this is the curve. X-axis, y-axis, and this is y square is equal to 9x origin. What are the points given here? X is equal to 2, x is equal to 2, and x is equal to 4. In the first quadrant, we just find out the area of this shaded region. That's it. This is the area. So, this is equal to integral a to b is nothing but 2 to 4. What is y? Y is equal to 3x to the power of 1 by 2 dx. 3 into integration of x raised to half is half plus 1 is 3 by 2 divided by 3 by 2 between the limits 2 to 4. So this is 3 into, take this to the numerator, 2 by 3 into 4 to the power of 3 by 2 minus 2 to the power of 3 by 2. Simplify this, you will get the answer. So 3 gets cancelled. This is 2 into 4 to the power of 3 by 2 is nothing but 4 to the power of 3 by 2 can be written as 2 square whole raised to 3 by 2. 2 gets cancelled. 2 cube, 2 to the 4 to the 8 minus 2 to the power of 3 by 2 can be written as 2 cube whole raised to 1 by 2. That is square root of 8. Square root of 8 is nothing but 2 root 2. So minus 2 root 2. So what is this equal to? 8 2s are 16 minus 4 root 2 square units. That's it. So the required answer is 16 minus 4 root 2 square units is the required area for this curve. Very simple problem for 3 marks, right? Now, these are the problems based on the curves which lies in the first quadrant and x-axis. Now move on to the second type problems. Find the area of the region bounded by x square is equal to 4y, y is equal to 2 and y is equal to 4 and y-axis in the first quadrant. Same, what is given here? Again, this is also a parabola opening upward. X square is equal to 4y. X is equal to square root of 4y is nothing but 2 times root y. That is 2 times y to the power of 1 by 2. And what is given? Y is equal to 2 and y is equal to 4 means here a is equal to 2 and b is equal to 4. So this is the curve. X-axis, y-axis. This is the curve. That is x square is equal to 4y. And here y is equal to 2. So this is y is equal to 2 and y is equal to 4. Y is equal to 2 and y is equal to 4 in the first quadrant. That means we have to find the area of this. That's it. Okay. Now what is the area? Now therefore the area is equal to integral c to d x dy. That is c. This is nothing but you can call it as c and this as a d. What is c to d? 2 to 4 x. What is x? X is nothing but 2 into y raised to 1 by 2 into dy. So 2 times integration of y to the power of half is 3 by 2 divided by 3 by 2 between limits 2 to 4. Same as that of the previous problem. That's it. So this is 2 into 2 by 3. Apply the upper limit. 4 to the power of 3 by 2 minus 2 to the power of 3 by 2. Simplify this. This is 2 to the 4 divided by 3. 4 to the power of 3 by 2. 4 to the power of 3 by 2 is nothing but 2 cube. 2 to the 4, 4 to the 8 minus this is 2 root 2. Simplify this. What you will get? So 4 by 3 into 8 minus 2 root 2. If you simplify, you will get the answer. That's it. Okay. So there, hence you can stop here itself. The required area is 4 by 3 into 8 minus 2 root 2 square units, or if you want you can also write like this. 3 is the LCM. 8 4s are 32. 32 minus 4 to the 8 root 2 square units. You can stop here itself or you can write that. 32 minus 8 root 2 by 3 square units is the required area. Right. Now, move on to the next problem. So, let us move on to the 5-marker question. These are very important type problems. Find the area enclosed by the circle x square plus y square is equal to a square. So, very important for 5 marks. You may expect this type of question for 5 marks. Definite sure question for 5 marks. Now, let us consider a circle with O as center and R is the radius or A is the radius of the circle. Then here x is equal to 0 and x is equal to A are the ordinates. Now the area, just find out area of OAB. Just find out area of any one of the sector. There are 4 sectors. Find out the area of any one sector and multiply by 4. So the required area is equal to 4 times integral a to b y dx. That is nothing but the required area. Area of the circle is equal to 4 times area of OAB. So 4 into area of OAB is a to b y dx. So this is equal to, what is a? A is 0, b is equal to a and y dx. This can be written as 4 times 0 to a. What is y from this? X square plus y square is equal to a square. Y square is equal to a square minus x square. Y is equal to root of a square minus x square. So this is root of a square minus x square into dx. Now, you know one standard formula is there. Integral root of a square minus x square dx is equal to x by 2 into root of a square minus x square plus a square by 2 into sine inverse of x by a. This is the formula. Just make use of this formula and apply the limits, you will get the answer. That's it. Okay. Now, what is the formula? X by 2 into root of a square minus x square plus a square by 2 sine inverse x by 2. Substitute here. So, this is equal to 4 times x by 2 into root of a square minus x square plus a square by 2 into sine inverse of x by a between the limits 0 to a. That's it. 0 to a. Now this is 4 into, apply the limit, a by 2 into root of a square minus x square is a square plus a square by 2 sine inverse of a by a minus lower limit 0 into any number is 0 plus a square by 2 sine inverse 0 is also equal to 0. Now listen. So this 4 as it is, 4 into a square by 2 into a square minus x square is 0 plus a square by 2 into sine inverse of a by a is 1, remaining constant 0 as it is. So this is 4 into a by 2 into 0 is equal to 0 plus a square by 2 into, what is sine inverse of 1? Since sine inverse of 1 is 90 degrees, sine 90 is equal to 1. Sine inverse of 1 is equal to pi by 2. So this is equal to 4 into 0 plus any number is same number, you will get a square by pi a square divided by 2 into 2 is 4. 4 and 4 gets cancelled. Pi a square units. So therefore the area of the circle is pi a square units. Suppose in the examination if they ask hence find the area of x square plus y square is equal to 16 means here a square is equal to 16. Therefore the area is equal to pi into a square. Pi into 16 means 16 pi square units. That's it. Okay. Now move on to the next problem. Similar type problem, an ellipse. Find the area enclosed by the ellipse x square by a square plus y square by b square is equal to 1 by integration. So this is same type as that of the previous problem. Here this is the origin 0, 0 and the ordinate. Here this is x is equal to 0 and x is equal to a. This is a, b. Find out the area of any one of the sector and multiply by 4. That's it. So find out the area of this OAB. The required area is equal to 4 times area of the sector OAB. So this is equal to 4 times integral a to b y dx. That is 4 times. What is a? A is 0. B is equal to a into y dx. Just find out the value of y from the equation. So this is 0 to a. What is y from this? Since x square by a square plus y square by b square is equal to 1. So y square by b square is equal to 1 minus x square by a square, or y square by b square is equal to, take LCM, a square is LCM, 1 into a square is a square minus x square, or y square is equal to b square by a square into a square minus x square. So only y is equal to, therefore y is equal to square root of this. Square root gets cancelled, b by a into root of a square minus x square. Substitute here. So y is nothing but b by a into root of a square minus x square dx. Now this can be integrated. This can be written as 4b by a integral 0 to a into root of a square minus x square, same as that of the previous problem. Now this is 4b by a. What is root of a square minus x square integral? That is nothing but x by 2 into root of a square minus x square plus a square by 2 into sine inverse of x by a between the limits 0 to a. So this is 4b by a as it is. X is nothing but a by 2 into upper limit a square minus a square plus a square by 2 into sine inverse of a by a minus, if you multiply by negative 0, and this is also 0. Now this is equal to 4b by a into a by 2 root of a square minus a square is 0 plus a square by 2 into sine inverse of 1. Remaining quantities are 0. So this is 4b by a into any number into 0 is 0 plus a square by 2 into sine inverse of 1 is pi by 2. This can be written as 4b by a into a square into pi, that is pi a square divided by 2 2s are 4. Cancel the terms. 4 and 4 gets cancelled. 1 a and a gets cancelled. B into pi into a, that's nothing but pi ab square units. So hence the area of an ellipse is pi ab square units. Very important. So you may expect either circle or ellipse for 5 marks. Very important sure question. Suppose if it is like this, hence find the area of a ellipse x square by 4 plus y square by 9 is equal to 1 means here a square is equal to 4, a is equal to 2, b square is equal to 9, b is equal to 3. Therefore the required area is equal to pi into a into b. That is pi into a is 2, a is 2, b is equal to 3, that's equal to 3 to the 6 pi square units is the required area. That's it. This is how we are going to find if it is like this. Okay. Now let us move on to the next problem. Area under simple curves. Find the area of the region bounded by two parabola y is equal to x square and y square is equal to x. Now What is given here? So y is equal to x square and x is equal to y square. That is y square is equal to 4ax is an equation of a parabola of opening right side. That is y square is equal to x is the parabola of opening right, and y is equal to x square. That is x square is equal to 4y is nothing but a parabola of opening upward. So the area enclosed between these two parabola is this. This is to be determined. Okay. Now just find out the points. What are the curves given? Given y is equal to x square, let us represent this as equation number 1, and y square is equal to x, equation number 2. Solving 1 and 2. Solving 1 and 2. Okay. Now from this, y is equal to x square, from 1, y is equal to x square, squaring on this, y square is equal to x square whole square is nothing but x to the power of 4. Now substitute what is y square. Y square is equal to x. So x is equal to x raised to 4. You can transfer this to the left hand side. You can take x common factor. 1 minus x cube is equal to 0. X into 1 minus x cube is equal to 0. Right. So this means here, therefore, x is equal to 0 and 1 minus x cube is equal to 0 means x cube is equal to 1. So therefore x is equal to 1. Therefore the points are x is equal to 0 or x is equal to 1 you can take, right? When x is equal to 0, let us take x is equal to 0 and x is equal to 1. First, when x is equal to 0, substitute in this equation, y is equal to 0 square, that's equal to 0. Again, when x is equal to 1, y is equal to 1 square, that's equal to 1, right? So, therefore, the point of intersections are, therefore, the point of intersection are, first point, when x is equal to 0, y is also 0. When x is equal to 1, y is also equal to 1. These are the point of intersections. Here the points of intersection, that is 0, comma 0, and this is the point A, 1, comma 1. These are the point of intersection. Just now, how to find the area of the shaded region? Now, so therefore the area, required area of shaded region is equal to, area is equal to integral a to b f of x minus g of x, f of x minus g of x dx. So that is nothing but 0 to 1 f of x minus g of x. Just subtract these two, that's it. So what is this equal to? So that is nothing but root of x minus x square dx. Now simplify this. So this is 0 to 1 x to the power of 1 by 2 minus x square dx. So integral of x raised to 1 by 2 is 3 by 2 by 3 by 2 minus integral of x square is x cube by 3 between the limits 0 to 1. Just apply the upper limit. 1 to the power of 3 by 2 is 1 by 3 by 2 minus 1 cube is 1 by 3 minus 0 into any number is 0 you will get. Now what is this equal to? Just take this to the numerator. 2 by 3 minus 1 by 3. Take 3 is the LCM. 2 minus 1, that's equal to 1 by 3. That's it. Okay. So therefore the required area is equal to 1 by 3 square units. That means the area enclosed between these two parabolas is 1 by 3 square. This is how we are going to solve this problem. You may also expect this type of question for 5 marks. So these are few problems based on applications of integrals. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.